Okay, good afternoon. For lecture today, let's do some exercises. There are two exercises. So first, using ITC-DCLab to simulate RLC circuit system. It is second order system, but in this case, we model it as a state space and simulate the state space using ITC-DCLab. Okay. Let me review the equation for number one. The dynamic equation has this form. CV dot V out equal to 1 over RC V out. V in, sorry. So in this exercise, the step number one, you need to transform into state space. Okay, and step two, define parameter. Using script, okay, using ITC-DCLab script. And then step three, you build block diagram in ITC-DCLab. Okay, now let's do this one. Okay, so I hope you can do the transformation from ordinary differential equation into state space form. For the equation, I want to add the initial condition like here. Oh, maybe you don't see the pointer in there. Troublesome. Okay, so I just added initial condition like here, and to transform it into state space, you let H1 equal to V out and H2 equal to V out dot. So the first equation is H1 equal to H1 dot equal to H2. And the second equation H2 dot equal to V out double dot, that can be found from here. So you got minus 1 over RC H1 minus 1 over RC H2 and plus 1 over RC V in. Initial condition H1 at time 0 equal to 0, H2 at time 0 is also equal to 0. Okay. And now let's choose L equal to 0.02 Henry and C 4 times 10 to the minus 5, and R is 200 ohm. Okay. Wait. Okay. So we choose Control P. We choose a parameter like this. Then we will try to do simulation using ITC-DCLab. So I open ITC-DCLab. Okay. Not this one, because we are going to use block diagram, right? Actually, there are two ways to simulate dynamic call system that has state space form. So first, type H calls to open a new window or new model. Okay, and then you use the user defined function here, user defined function, and you bring the block, this one side function block. Okay. Side function block, and you double click, you can configure the parameter in here. But actually we are not going to use the sine function, but we use our own function that is the right hand side of the state space form, right? So I have not, I think you don't see the screen yet. Sorry, I use extended mode, right? Okay. Okay, so I repeat. So you go to user defined function and drag this block. So we are going to configure to create a new function, and you use this block to call that function. Okay. Because the input is just scalar, Vin is just scalar, so 1 is okay. Output port size is also 1. No, output port we have it's a vector because we have two states, H1 and H2. So we change this one to be 2. Okay. And the function, we will use a new function, just call it dynamic or LC, okay, dynamic or LC, and the input it's up to you. You U1 or V is fine. Just call it U1. Output, maybe it's better to call it H dot, right? H dot. And here our output, input U is fine, no need to be U1. And Y1 is not side 2 is, you did not define Y1 here, or it has to be Y1, so this one it has to be U1. Okay. Initialization, so no need to change anything. Can I be closing? Whatever needed to finish. Okay, no need to do anything. Constraint, no need. Okay. So now we have this function, but this function has to be defined in the script. So I go to new script. Here, new script or sign out, and only open, no. So new, yeah. And now let's sell. So the function name is I just put the dynamic or RC. Okay. The name has to be the same. Okay. And in this function we define you call it H dot equal to dynamic or LC, and the input is V in, right? Yeah. Then you define the parameter L equal to 0.02 Henry, C equal to 4e minus 5, and R equal to 200 ohms. Okay, and then you define equation H1 dot, because your parameter here are, I think we need to write function like this. Yeah, function. Okay, H dot evaluate H dot component 1 equal to H2, right? So in here it also has H. Sorry, H also. Yeah. Yeah, so my function before is not right. I need to change it. Yeah, actually it also in function of H. Here is H2. Okay, to avoid the mistake, let's open it. Yeah, let's open it. So output H2, port side, input port side, input port side 1 output port 2, input 1. How do I find two input port side? I use like this. Maybe. Okay, this one we need to put H also, right? We need to pass two arguments. It's not like MATLAB. Sorry, I think I made a mistake. Let me open what I have built before first. Okay, just cancel it. I have built this one already. Let me see it. How do I define it? Just y1 and u1. But for y1 we also have input and also output, and also let me check which one is this one, not this one. Yeah, this one. So I have two, and then this one I don't have input. Okay, this one does not have input, so it's a little bit tricky. It's not very flexible like MATLAB. Why I say tricky? Because in the input here we can only have one port. So if one port, because we have one V in and also H1 and H2, then you need to define it as 3 input side. Okay. But I also have this one. What if I use this? So let me explore it a bit. No, nothing. So okay, we use it as a vector. So we define input side as a 3, U, H1 and H2. So 3, and output is just H1 and H2. Okay. Yeah, like this. And then okay, yeah. Then when you write the equation here, not this one, just close it. Yeah, so here is just u, just call it u. Okay, just call it u1, and this one is also just y1. No, this one h dot h. Yeah, you can use h dot. Here v in equal to u1 dimension, the first row. This means the first row, right? Okay, and h1 dot equal to h2. h2 is the second row of u1. No, third row of u1. You understand what I mean? Okay, maybe it's better I write like this. h1 equal to u1. The second row I write down like this, easier. Okay, and h2 equal to u1. Okay, third row of u. Right? So here I can directly write down as h2. Okay, and then h dot element number 2 equal to what? Minus 1 over LC times h1 minus 1 over RC or over C times h2 minus 1 over L over C times V in. Is that okay? And then n function. Save it. So once you have the output as h1 dot h2 dot, you need to use integrator. Okay, in Scilab, when you build this function, you must run it. So just run it. Okay, and then I complete the block. Go to library, then bring mux and demux in signal routing. Mux, do I need mux? Maybe I only need demux. Yeah, I will need demux, and I go to continuous and take integrator. Okay, and the integrator has to be configured as 0, 0, because we have two initial condition for h1 and h2, right? Waiting for dimension 1. Oh, I see. This is a limitation of Scilab as well. We can only use one initial condition, so you need integrator. You need two integrator like this. So you need demux as well here. Okay, so like this. Yeah, and here you split, you mix between U and H. Yeah, so you need mix as well. So I go to signal routing again, signal routing, and then I need mix. Yeah, no, I demux here. I need mix. I need mix here. Why I need here? Because H1 and H2 has to go together like this, right? And then this one need to, yeah, need to go here. Okay, so now you need input V in and scope to see the result, right? So I go to source to find step, and also clock for the scope. And where can I get the scope? So I go to sinks and then scope. Optimal, go up there. It's not easy to drag. Scope here. Okay, and then we need to configure the parameter. For example, in the scope, we only want to see from 0 to 1 second, maybe just 0.5 second, and y mean just from 0 to, oh, this is 0, this is 1.5. Okay, and okay, and this one initialization time just say 0, and period from one point to another point like this. Okay, and okay, then go to simulation time, set up, and you simulate up to 0.5 second only. Okay, and save it. Z call 4. Okay, dynamic ORC in state space. Okay, let me check. We have mix. Okay, for mix, because yeah, it's 2 dimension, so it, I hope it automatically recognize 2, so we get 3 in here. Okay, let's run. everything 0. Okay, why everything 0? Because step time is 1, so we change step time to 0. So run. Oh, I see, it oscillation and drop to 0. This doesn't quite right. I see, because we have two scope. We have two, one is H1 and another one is H2. H1 and H2. H1 and H2, if we plot together, it's a little bit, I'll say it a little bit hard to visualize, because the scale of H1 is small but the scale of H2 is too big, so a different scale. So instead I delete this and I plot these two differently. H1 I will plot here, or maybe we can use a scope that has two ports like this. So this one for H1 and this two for H2, and connect this clock cell, and then we need to define the minimum and maximum. For example, minimum for the first plot, we can start from 0, but minimum for the other one, maybe it need to be large, let's say up to 10, minus 10. So this one just go to 1.5, and for the second graph go up to 10, okay, let's say. And this one refresh period just 0.5, right? 0.5 and 0.5. Okay, so let me try again. So for number 1, I don't see anything for number 1. Why is that? Number 1, 0 to 1.5, and number 2, minus 10 to 10. Input port side 1, 1. It's string. Why only show 1? Okay, what if I use a different one? I use this one, yeah. And config this one a little bit, minus 0 to 1.5, and this one just 0.5 second. same. Why I cannot see the graph? Too big? How come it is too big? Let me see the equation again. Is there any mistake on the equation? Number 1, number 2, number 3. Number 1 input, number 2, number 3. Okay, H1 is 2. H1 dot equal to H2. H2 dot equal to 1 over RC H1. Oh yeah, that's why, that's wrong. Here is plus, right? So actually the result 2 minus, that's why we don't see it. Okay. Run this one again. Hide it. And then this one should be fine. I don't need this one. Yeah. So we have result of H1 and H2. Okay. So now you try yourself. You try to simulate lateral motion of car kinematics using ITC-DCLab, and I will show the equation here. And for the parameter of B, V0 and A, you can follow here. Yeah, here is I need to use double screen, double duplicate. Where is it? Yep. Okay. So here you have parameter A, B, and V0. So now you try to simulate the system. Okay. Try by yourself. I will build it quickly. I can take advantage of matrix form to build it in a different way from previous example. So yeah, I choose A B C here. Yeah, and also A B C D here. Okay, so I need to create a function, right? Function, just call it H dot equal to, just call it car kinematic. Car lateral kinematic, and input is U. And then I have input delta, right? Delta is just U1 like this, and then I have X equal to U from the second and the third, right? 2 to third row. Right? I write it in matrix form. Right? and then h dot is a times h plus b times u, but not u here, actually delta, right? Delta, because u is everything in here. Okay, this is more, even more convenient, right? Matrix form. Oh look, yep, okay. So I save it. I copy this one because I need to save with the same name. Control C. Save. Control V. And then in here, I think I should close this. This one, okay, same. This one, I just copy this. Okay, drag and drop here. And now I change this one to be car lateral kinematic. Okay, should be done, right? Initial condition 0 0. Then I just need to run this one to compile the function, and then I can run this one. I don't want to see this one, so I command it. Can I find command? Maybe it cannot find easily, so just delete it first. Run. Okay, I need to change the scale, right? Oh, car lateral kinematic. No, it's okay. It just function. It just input argument. Here is u. Here also u. This is fine. What does this say? H dot in function current undefined variable h dot. Maybe when I run it, it doesn't work. And function is here. Yeah. Run. Okay. And yeah, but I need to change the scale if I want to see more graph. Y mean, let's say same, but Y mark has to be large. And refresh period maybe 10, and simulation time also 10. I can see until 20, that's fine, but it will refresh 10 and then another 10. Okay, run. Oh, a little bit slow. Why is so slow? Because I use this one too small, right? Here, too small. Because the dynamic is not so fast. We can use larger distance between one point to another, right? In the sample time. So this one can also represent the sample time. So I want to improve the speed like 10 times faster. Okay, So this one go to 100 already, but this one just go to, yeah, already out of the graph. We don't see. What I can do is to change more scale. Let's say 10 times more. Run again. Okay, so this one is one out of the graphs at 3 seconds. Okay, so far so good. Is there any question? Any more question? Okay, if not, we can stop now.